The protein myth. Lessons from traditional diets. Many ask the question of how much protein is enough. Traditionally, protein recommendations have relied on laboratory studies or estimates. But what if we look to cultures who have thrived on natural diets for generations? This section explores protein needs through the lens of traditional diets. We'll examine three fascinating examples. Japanese farming communities. For centuries, these communities thrived on a primarily vegetarian diet rich in greens, fruits, roots, and occasional small fish portions. Averaging only 37 grams of protein daily, half the current recommended intake, these farmers enjoyed excellent health and performed demanding physical labor. Pacific Island tribes. Generations of islanders have subsisted on diets of fruits, roots, and tubers, averaging a mere 15 grams of protein per day. Despite this seemingly low intake, they exhibit exceptional health. Californian fruitarians. Dr. Jaffe's multi-generational study of fruitarians consuming just 24 to 33 grams of protein daily, primarily from fruits and nuts, revealed no protein deficiencies and exceptional overall health. These real-world examples challenge the notion of high protein requirements for optimal health. While individual needs may vary, these communities demonstrate that thriving on significantly less protein than current recommendations is possible. This doesn't advocate for strict gram counting, but rather highlights the potential of a varied, natural diet rich in fruits, vegetables, nuts, seeds, and sprouts to meet protein needs alongside other essential nutrients. By exploring traditional dietary wisdom, we can gain valuable insights into achieving optimal health through a balanced and natural approach. Most Europeans and Americans consume far more protein than necessary, potentially leading to health problems. Protein deficiency is uncommon, but excess protein intake is a concern. When the body can't process all the protein consumed, nitrogen buildup can lead to a condition called protein poisoning. Protein poisoning can mimic allergies, causing fatigue, headaches, rashes, and a burning sensation in the mouth and throat. A high-protein diet is thought to strain the liver, adrenals, and kidneys as they try to eliminate excess protein and its byproducts. Some people even report reduced arthritis symptoms after lowering protein intake. Supplements can provide excessive protein, throwing off the body's nitrogen balance and potentially leading to other nutrient deficiencies. The body struggles to eliminate excess protein from supplements, creating an additional burden. Made from processed ingredients like soy powder or dried egg whites, they may oversupply some nutrients while lacking others, disrupting the body's natural balance. Supplements may contribute to gout caused by uric acid buildup. Dried egg whites can cause constipation. Soy powders can contain enzymes that hinder amino acid absorption. Powdered milk can promote mucus formation. The overall message is that a balanced diet, rich in whole foods, is a better way to fulfill protein needs, and protein supplements offer little to no benefit and may even have negative health consequences. Even the simplest organisms boast multiple protein types. Plants typically have at least 2, while the human body is estimated to have over 100,000. Despite their differences in structure and function, all proteins share a common core composition. Roughly 53% carbon, 22% oxygen, 17% nitrogen, 7% hydrogen, and 1% sulfur, with trace amounts of elements like iodine. Albumin, abundant in fruits and vegetables. Gluten, found in wheat and cereals, it provides structure but is not a healthy choice. Legumin, packed into peas and beans, it's a vital storage protein. Globulin, present in nuts, it plays a role in various cellular functions. Mucoprotein, found in peas, beans, and seeds, it has a viscous glue-like quality. These diverse proteins all share a common thread: amino acids. Imagine protein as a complex necklace, and amino acids are the individual beads. They link together in specific sequences, giving each protein its unique shape and function. Proteins may seem complex, but they're built from a surprisingly simple set of 23 building blocks called amino acids. These amino acids act as the universal Legos for constructing all proteins, whether they come from plants or animals. A single protein molecule can be massive, containing hundreds or even thousands of amino acids, strung together in a very specific order, kind of like a unique sequence of beads on a necklace. This specific sequence is what determines the protein's shape and function. The human body can't directly utilize whole proteins from food. Here's where digestion comes in. The digestive system breaks down proteins into their individual amino acids. Once broken down, the body can then use these amino acids to build the specific proteins it needs for various functions. Once broken down, the body can then use these amino acids to build the specific proteins it needs for various functions. The true value of a protein source lies in its amino acid profile. Not all proteins are created equal. Some provide a wider variety of essential amino acids that our bodies can't produce on their own. Therefore, a thorough understanding of amino acids is crucial to comprehending protein's role in nutrition. By understanding amino acids and how our bodies utilize them, we can make informed choices about the protein sources we consume for optimal health. Our bodies rely on protein for countless functions, but how does the protein we eat get transformed into the building blocks it needs? Let's explore the fascinating journey of exogenous protein, the protein we obtain from our diet. As soon as we consume protein, enzymes in the stomach and small intestine spring into action. These enzymes act like molecular scissors, snipping the linkages within the protein molecule. This process progressively breaks down the protein into smaller and smaller chains of amino acids. Once these amino acids are broken down to a simple enough form, they can pass through the walls of the intestines and enter the bloodstream. They travel through the portal vein, a special highway leading directly to the liver. The liver acts as a processing center for the absorbed amino acids. Here, they may undergo further modifications before being released back into the bloodstream and lymphatic system. Finally, these amino acids reach their ultimate destination, the body's cells. It's here that the magic happens. Cells take up the amino acids and meticulously assemble them into new proteins tailored for specific functions within the body. This simplified explanation provides a glimpse into the remarkable process of digesting and assimilating exogenous protein. By understanding this journey, we appreciate how the protein we eat is transformed into the essential building blocks that keep our bodies functioning optimally and are able to choose our protein sources wisely.